Hello. Today we're going to review from some 6th grade material on the difference between elements and compounds. Now in 6th grade you did go into a lot of detail, but we need to make sure that you still truly understand the difference before we proceed in our PBL lesson. So let's get started. Remember, you can pause the video at any time when you need to make notes. You can rewind and write questions that you're not understanding in your left-hand column. So, first thing I want you to do in your notes is make a T-chart. Label one column elements and the other column compounds. It really doesn't matter which side you pick, just make sure that you understand that they are different. Now, here is a list of elements and compounds mixed together. I want you to place them correctly in the appropriate category. For example, hydrogen. Do you think it is an element or a compound? If you think hydrogen is an element, all you need to do is write the atomic symbol just like you see in the element column. If you think it is a compound, write it in the compound column. Okay? Take your time. Do not cheat. Don't look at anything. I just want you to see what you remember and what you know. So go ahead, pause the video, go through this list, and make your T-chart. When you get to class tomorrow, we are going to have a card sort to make sure that you do understand the difference between elements and compounds. So make sure that you are paying attention. So let's define an element. Elements are substances that cannot be broken down into any other substance by physical or chemical means. Pretty much it means that elements are pure. That if I was to take a nugget of gold and to put it in my hand, if I was to tell you that that nugget of gold was a pure element, then that means what? Means that every single atom in that nugget is a gold atom. If there was one single atom, let's say hydrogen for example, in that nugget, then would it be an element? By definitions, no, it would not because it is not pure. Now remember the periodic table from 6th grade? Well, in 8th grade that's going to become very important, so we want to make sure that we still remember it. The periodic table of elements organizes all of these by their physical and chemical properties. Also in 6th grade, I do know that y'all went over physical properties, like how does it look, its size, its shape, its state of matter. Chemical properties, its flammability, its reactivity. So the periodic table helps us to organize these things. An element is anything that is made up of a single atom or two of the same atoms that are joined together in a molecule. Now do not confuse a molecule with a compound. So for example, He is the atomic symbol for helium. So if you were just to have one atom of helium, is that an element? The answer is yes, because it is a pure substance. But what if you had two atoms of the same element, like H2, which stands for two atoms of hydrogen? Is that still considered an element? Yes, it is. Because you have the same type of element, it doesn't matter how many atoms you have. So you could have one atom of hydrogen and it can be considered an element. You could have 1,000,000 atoms of hydrogen and it would still be considered an element. But the moment a different type of atom comes in, so let's say you have 1,000,000 hydrogen atoms and one carbon atom, and they are all bounded together, is that considered an element? No, it's not, because it is not pure and it can be broken down. So here's a periodic table of elements. Just to go over what all the information is telling you, look at the symbol at the very top. The number at the top is the atomic number. The number at the bottom is the atomic mass. And then the letter that you see is the element symbol. Symbols can be 1 to 2 letters, where the first letter is always capitalized, and the second letter, if there is one, or even a third sometimes, has to be lowercase. So let's do a periodic table review. I want you to use the periodic table that you glued in the back of your journal, and I want you to write the symbols of all of these elements. Now, if you do not know them, If you don't know them, look them up, okay? So, for example, and I want you to do this on the left column of your notes where you normally write your questions. I want you to put it there, okay? And when you're done with your notes, do not change anything because I want you to bring it to class and I want to see how everybody did. So just understand, it is okay if you do not know all of these. But carbon. What is the atomic symbol for carbon? Helium, lithium, oxygen, sodium, gold, nitrogen, and hydrogen. So take a moment, pause the video, look at your periodic table, and write the symbols beside it. So now that we know what an element is, let's talk about a compound. When elements are combined, they make a compound. Now you're asking, okay, well, just a second ago you said that if I take 2 hydrogen or 1,000,000 hydrogens and bond them together, it's an element. So what's the difference? The difference is a compound is made up of 2 or more different types of elements that are chemically bonded and set together in a set ratio. So an example would be H2O, okay? Now looking at the picture at the bottom, notice how I have 2 hydrogens together. When these 2 hydrogen atoms bond together, is this considered an element or a molecule or a compound? The answer is it is an element and a molecule. It is not a compound, however, because both atoms are the same type. It is hydrogen. Now look down here, you have a hydrogen atom and a chlorine atom. When these 2 atoms chemically bind together, it makes HCl. Is this an element, molecule, or a compound? It is a compound because it is made up of 2 different elements, a hydrogen right here and a chlorine. Okay? So let's check yourself. Remember that T-chart that you made earlier? I want you to pause the video and see how many you got right. Now, if you got one wrong, do not erase it. Do not mark it through, okay? Because you know by now that scientists always learn from their mistakes. We make 1,000 mistakes a day. Like you could probably hear how many mistakes I've made in this video so far. Did I start over? No, but I digress. So if you missed something, I want you to highlight it, okay? And let's highlight with green. So if you got something wrong, I want you to highlight it in green. If you don't have a highlighter, then circle it. But by no means do I want you to erase it or mark it out because we want to go over these tomorrow. So pause the video and check your answers. So let's talk about a chemical formula for compounds. Formulas show what element and how many atoms of that element are involved in a compound. So in class tomorrow, you're going to use a whiteboard and we're going to show how many of each elements are present in a compound. So let's, for example, talk about H2O. Now, by now, you should know that that is a compound because it is made up of 2 different elements, hydrogen and oxygen. H2O right here is considered a chemical formula. You should be able to figure out what elements are involved by looking at the atomic letters, or what we call the symbols. And then this little number right here should help you to figure out how many atoms there are. Now, here's a hint. If you do not see a number after the atomic symbol, always assume that it is a 1. Never assume it's a 0. Because first off, if it was a 0, if there were 0 oxygens in a water compound, then why would they even put it up there? They wouldn't, okay? So the rule of thumb is, just kind of like in math or in algebra, you don't have to put a number if it's a 1. So water has 2 hydrogens and 1 oxygen. Let's try another one. Carbon dioxide. Carbon dioxide's chemical formula is CO2. So carbon, obviously, is the C. Now, dioxide, what other element is represented by that O? How many carbon atoms are there and how many oxygen? The answer is 1 carbon and 2 oxygens. Okay, let's go with sodium chloride, table salt. This is what you salt your food with. it is 2 different elements, 1 sodium atom and 1 chlorine atom. Notice that neither one had a little number to the to the end of it, blah, which is called a subscript, by the way, which you don't need to know that till 8th grade. So there is 1 of each. And then the last one is ammonia. Ammonia's chemical formula is NH3. So it is made up of 2 elements, nitrogen and hydrogen. How many nitrogens are there? And how many hydrogens are there? 1 nitrogen and 3 hydrogens. Good. So here's a picture of some chemical formulas, just to give you another visual representation. So if we took nitrogen oxide, notice that it is NO. No, that should be easy for y'all to remember. It is 1 atom of nitrogen and 1 atom of oxygen. H2O, because we have a subscript after this H, we have 2 hydrogens and 1 oxygen. Nitrogen dioxide, again, only 1 nitrogen, but this time 2 oxygens. And carbon dioxide, 1 carbon and 2 oxygens. So from every chemical formula, you should be able to figure out 2 things. How many different types of elements there are, and again, we look at the symbol, and how many atoms there are of each element, and for that, we look at the subscript. And if we don't see a subscript, we always assume it to be a 1. So that's where we're going to stop today. All right, when you come into class tomorrow, we'll discuss any questions that you have. We will kind of have a little activity to see if you truly understand the difference between elements and compounds before we get into our unit of photosynthesis. So if you have any questions, you can rewind this, write them down, and I will see you guys tomorrow.